Good morning. My name is Vlasta and I'm a technical writer at Memgraph. Today I'm going to show you how to migrate your data from Neo4j to Memgraph using CSV files. If you don't have a running Neo4j instance but you have your data in CSV files, you can just skip to the part where we import the data. To start, let's look at the data we want to export. We have a dataset, and I'm calling it shipping, that consists of 3 nodes: node employee, node order, and product with their properties. Each employee reports to a certain employee. Each employee sold a certain order, and each order has several numbers of a certain product. Let's look how the data looks in Neo4j. So this is a meta graph of the data, which look basically as the data set I just showed. We have 960 nodes and 2,993 relationships. To export the data, we need to use a Neo4j APOC procedure, which is not enabled by default. So first, we need to enable this procedure. I'm using the Neo4j desktop, and to add the configurational flag that will enable export of files, I first need to find the configuration files my instance is using. So I click on my project and then I open a folder configuration. Neo4j will open the location of all the configuration files, and I'm just going to create a new one called APOC conf. In this configuration file, I'm going to paste the flag I need for the export. Save the file and exit. To be able to use APOC procedures all together, I need to install the plugin. So I just move to the plugins tab and then open the APOC drop-down and click on the install and restart. After the restart, I can proceed with export. So I'm going to call the procedure for exporting data into a file shipping CSV, and this procedure will export all the data into a CSV file. So where is the file now? You can click on the 3 dots here again and open a folder, import. It's not very intuitive that once you exported something, it will appear in the import folder, but that's where it is. Once in import, let's move this file somewhere a bit easier to access. So I'm going to move it here in my data folder. The export is done. We have our CSV file and we can turn off Neo4j. It's time to start our Memgraph instance, so let's head over to our terminal, and I've downloaded the latest Memgraph Platform image, and we can use the Docker run command to run it in the interactive mode and opening 3 ports. The first port is to connect with external applications or clients. The 744 port is for logs, and the 3000 port is for Memgraph Lab user visual interface that you can access using a browser. And then we define the name of the image. Okay, once Memgraph is running, we need to transfer the file we have on our local system to the Docker, so that Memgraph can access it. To do that, we need to open a new terminal. To be able to copy the files, we first need to find out the container ID. Once I know the container ID, I can write a Docker command to copy the file from my C disk and data directory. The file is called shipping CSV, and now I need to write the container ID. So the target location is the container ID, and the directory is userlib memgraph. The file name will stay the same. And once I run it, the data is copied. We can check this by entering the container. And now we can list the contents of the folder or the directory, and you can see that the shipping CSV is there. Now we can go and open our visual user interface so that we can start with import. So just go to your browser and go to localhost 3000. Memgraph Lab in browser should open and immediately your instance, and then you can just click on connect now. And here you are in the Memgraph Lab. This is probably the first thing you will see if you're a new user. I'm just gonna go quickly over the interface. So here you can see the number of nodes and relationship we currently have in the instance, the memory and RAM you're using. Here is where you write your queries and execute them. And this is where the results will show up. You have the history of all your queries. Query collections are where you save your favorite queries so you can rerun them. And then you have query modules. These are like APOC, so all the procedures you can use. You can connect to streams. You can create a graph schema or the meta graph of your data. These are some preloaded, some data sets you can load and explore on your own. Import and export of Cipher-L files, that is pure Cipher files. And these are the logs. You can also split your screens vertically and horizontally. So I can have logs here and query execution here, or I can have two query execution screens. I can even have another screen here to, I don't know, check the data sets or check the streams. So a lot of things are possible in the visual user interface, but today we are going to use the query execution because we will just run some queries I pre-prepared here. So this is my query collection for this tutorial. And so these are all the queries we're going to need. I can run them from here, and you can run them in the query execution section. So first thing we're going to do before actually importing the data is speed up import. We don't have a lot of data. So if I remember correctly, we have around 700 nodes and 3000 relationships, which is not a lot. But if your data set is really big, you will need all the speed you can get. To gain the speed during import, you can create indexes on properties that you will use to connect certain nodes with relationships. So we will do that with node IDs. Please be aware that once you create indexes on properties, it will not automatically create indexes on labels. Other thing we will do is we are going to change the storage mode to in-memory analytical. So Memgraph has two different storage modes, in-memory analytical and in-memory transactional. What happens in the in-memory analytical, it disables the creation of durability files, so you have no asset guarantees, but what you do gain is a less memory usage and more speed, so better performance. If you are doing import with multiple connections, it may mess up your data, so be sure to do this only on one connection, and while importing data is in batches, so everything is imported correctly. So I'm going to go ahead and run these queries. So what I'm doing, I'm creating indexes on these properties, and I'm changing the storage mode to in-memory analytical. Okay, so now let's check if everything went as expected. So I can't run both of these queries together. So first I'm going to just comment out this one. So if I show indexes, I can see that I have 3 indexes. And let's see if our storage mode is analytical. This query will give me more information rather than just the storage mode. You can see the global isolation level, the allocation limit, memory usage. It's a lot of info, but what I'm concerned for now is that my storage mode is in-memory analytical. Okay, so we are ready to import the data. Let's see what's in our CSV file. So you can see that all of the nodes and relationships are in this one huge CSV file, and the CSV file has header, which has a header which is defining what each of these values means. So we are going to import our data using the load CSV clause. So let's check how we need to write the first line of the query. These are all the options, so let's check how we need to adjust them or remove them altogether, because some of them are optional. So first thing we need to change is the path to our file. So the path to our file is the userlib memgraph directory, and the name of the file is shipping CSV. Next, we need to decide whether we have a header or not. So if we look at our CSV file again, we have a header row. The first row is header, not data. So we are going to go ahead and just write with header. Now we have to decide if we are going to ignore bad rows, which we are not. The default delimiter sign is comma, and we're going to leave that. The default quote is the double quote. That's fine for us. We are going to leave that. And now we need to define the variable in which we will store every row. And we are just going to call it the row. So here's where we removed all the extra options that we do not need, and we are defining the variable name as row. Why is the variable name row? Well, what happens in the load CSV clause? The load CSV clause will take each row and create it as a map, and we need to save that map as a certain variable, and we're going to use the variable row. The map will actually connect keys to their values, so it will take a look at the first key and assign it the first value from the row it's currently parsing, and then next key is labels, and it will take the next value. Employee ID is 1, first name is Nancy, last name is Davolio, and then you have order ID, product name, and ship name, which are obviously not properties of the employee node. So that's empty, and then you have title and etc. Everything else is not related to the employee node. In the next row of our load CSV query, we need to filter out the rows. So the CSV files contains a lot of rows, which not all of them are employees. So how do we filter out only employees to create employee nodes? We say, okay, just look at the rows where the key labels equals employee, and that will filter out the employee rows. So what are we doing with these rows? We are creating a new node. The label of that node is employee, and this node has certain properties. It has node ID, which is in the CSV file, that value where the key is _ID. And we do the same thing for employee ID. So take the value from key employee ID, the first name, the last name, and the title of our employee. And this is the first load CSV query where we will import the employee nodes. So if you paste this load CSV query in your query execution window, or I'm going to do so here, I also added 2 extra lines that will immediately after importing nodes find those nodes and show us to us. So here we are. We've imported 9 new nodes, and here we can see those nodes. If you click on a node, you can see its properties. Now we can create new nodes. We will create order nodes. So the query is very similar. The first line is the same. The second line, we are just filtering out order nodes instead of employee nodes, and we are changing the properties and taking the properties we need. So we need the ship name. And then those 2 lines are immediately finding the new nodes and returning them to us. So let's see the new nodes. So now we are importing 830 nodes, and here they are. As you could see, the number of nodes changed before we saw them. That's because the import finished. This percentage countdown was just to render the new nodes. Now we will import the product nodes. Again, the same query, you're just changing the filtering, so you're only filtering product rows and you are defining the properties that the product has. One thing to notice here is that we change the data type of this property. So all the properties are imported as strings unless defined otherwise. So everything we've imported so far has been string properties, but here we have the unit price, which is actually a number. So we are going to define that it's to float. And now I can run the query and get the new nodes back. And here they are. So we've created the product nodes with their own properties. Now I'm going to return all the nodes that we've created. And what I don't like here is that every node has this text underneath, but it's not anything unique. It's just the label it has. So I'm going to change that. So how I'm going to change that is by using the graph style editor. The graph style editor enables me to change the visual appearance of my graphs. So if I kind of scroll down here, I can see this part of the code that says that if a certain node has property name, then create the label. So the label in this case means what it says underneath the actual circle that's representing the node. Use that property. But none of our nodes actually have this property. So I've copy-pasted this code block. And as my nodes don't have names, what do they have? So my employee nodes, oh, where are you? Okay, so my employee nodes have first name. It's not name, but first name. So I'm going to change that if a node has property first name, create the label from that first name. My orders have order ID. So I'm going to use that for orders. And the products have product name. And now I can apply these changes. And now if you look at the graph again, you will see that it no longer uses the label as a label. It uses the name of the product, it uses the number ID of the order, and for the employee nodes, it takes the name of the employee. So Anne, Margaret, Andrew. There are many improvements you can do to the visual appearance of your graphs, so be sure to check the graph style script from Memgraph Lab in our documentation. Okay, we are ready to move on and import relationships. To import relationships, we use the same load CSV query. The first line is the same as in all the rest of the queries. We are filtering the rows where the type now is reports to. That's what's defining that it's a relationship. So let's just check our CSV so you know where that's from. Relationships are a bit... Okay, so here's a relationship. You see that it has two numbers which are defining the starter node and the end node of the relationship, and this is the type of the relationship, and some relationships have properties. So this relationship reports to doesn't have any properties, but we need to define the starting node and the ending node. So we say, please find me the node that has the node ID the same as the value of the start key, and find me the node that has the same ID as the value of the end key. And then create a relationship between those two nodes. And then we are returning all the nodes that were connected with this relationship to immediately see what we've done. So if we run this query, we are going to see what we've done. So we've imported 8 relationships, and those relationships connected the employee nodes. Let's move on to the next relationship. The next relationship is of type sold. And again, we are finding node IDs that correspond to the values we have on the key start, and then again, nodes that we have on the key end. And again, we are creating a relationship between those two nodes. This time it's of type salt. And again, we are returning all of those relationships and nodes. And here they are. And for the last relationships, we have the contains type relationship. So again, the first row is always the same. Then in the second row, we're filtering out contains rows, and then we are finding the start nodes and end nodes, and then we are connecting them with contains relationship. What's different here is that this relationship has a property, and that property is called quantity. We are going to turn it into integer, and it will have the value of the key quantity. And then we are going to see all the nodes and relationships we created. And voila! This is all the orders and the products the orders contain. And this is our final query where we can see all the nodes and relationships we've created. And that's it. Our data is imported into Memgraph. We have all the nodes and relationships inside. In the end, please do remember that you're still in the in-memory analytical mode, storage mode, which means you have no asset guarantees. If you're just going to analyze the data you've imported, so there will be no changes to the data, you just want to explore it, you can stay in the analytical mode, nothing will happen, you will just gain the low memory usage. But if you mean to change the data in some way, or connect to a stream, or manipulate your data in any other way, do change your storage mode to the transactional mode again. So I'm going to run this query to see in which storage mode we are. Indeed, we are in the analytical mode, so I'm just going to change it to the transactional and get my asset guarantees back. And that's it. We've successfully imported data from CSV files. I hope you succeeded. If you got stuck somewhere or you need help, join us on our Discord channel, where we'll be more than happy to help you. And if you want to try yourself, you can go to our docs, where this tutorial is also available as a text. And to download Memgraph, go to memgraph.com downloads. And that's it for today. Hope to see you soon. Bye.